Let's go over another example. Here we have a curve from -1 to 1 is an arc of the circle, this one. Now this is a equation of a circle and the radius is 2, because 4 can be written as 2 squared, right? So the radius of that circle is 2, and this line represents an arc of the circle from -1 to +1, and since square roots are positive, y value should be positive. So basically they represent the arc from -1 to 1, the positive arc, okay, because it can also be in the lower side which has negative y values, but if it is negative, then they should represent it with the negative sign like that, right? And since they have not represented it with the negative sign, then the arc should be definitely in the top side, okay? So this is the arc that they are referring to, right? And you really don't have to know the exact shape, okay? Even without drawing any pictures, you can obtain the surface of the the area of this surface obtained by rotating, right? Only thing you need to know is the axis of rotation, which is in this case x-axis, and the equation of the line, and the start point and the end point, right? Now for this one, we can see they have given the equation as y equals 4 minus x square. Now anyway, since this is x-axis rotation, we to find the area of the surface, we will need to use this formula, since this is a x-axis rotation. And for ds, we have two options, right? Dy by dx squared and dx by dy squared, right? And you can use both here as well, but since they have given the equation by subjecting y, and in order to subject x, you once again have to square this one and then get a square root. So without doing all those stuffs, I will use the direct extraction, okay? So that in that case, I can easily, like from with directly, I can compute dy by dx from the given formula, okay, which is half 4 minus x squared minus half times 2x, right? And that is equal to negative x over 4 minus x squared, right? So I will plug this value for my ds, right? And then our area, surface area equation will be this one. And then since we have an integral that runs through the x-axis, x variable, we need to indicate the start point and the end point with x variables, right? So this is the x variable, x coordinate of the start point, and this is the x coordinate of the end point. And if we need to find the y coordinate, then we will have to compute it separately by using this formula, okay, which is this one. We need to use this formula to compute the y coordinate, but since x coordinate can be directly obtained, it's easy to use this one instead of the other for ds, right? But that won't be a big problem even if you use the other way around. So once you have these details, then it's just a matter of computing the integral, and it can be done as follows, like this. And here once again we have to be careful, because we are differentiating with respect to x, we are integrating with respect to x, so we cannot have a y variable inside. But since this is x-axis rotation, from the formula we will have a y variable, so we should substitute the appropriate terms in terms of x, right? So since the equation is given like this, you can directly plug in the right hand side of this equation in place of y. So the whole integral will become an integral in terms of x, and we are differentiating with respect to x, and after that you just have to carry out the simplifications. And I highly recommend you to do all these calculations to be more familiar with integration. It will help you a lot, right? And the final answer will be equal to 8 pi. And from the next video we can conclude our week 4.